it's good to see everyone again. We still have pretty good numbers coming out, so that's nice. So as you saw on Quirkus, the grades are out, so we've released the marks for the term test. If you would like any modifications made to your marking, maybe your multiple choice didn't get scanned, or a TA missed some work, or this kind of thing. If there's absolutely any modification that you would like to make to your marking, please use this form. Okay, if you email me about it, I will just ask you to use that form. So please go to this form and fill out how you would like your assignment or your test regraded. Okay, so you'll have email address, name, student number, or in this lecture section. And then for each question you want regraded, there's a link that you'll put here so that the grader knows exactly what you want regraded. Okay? And then you can write, why you should have this thing regraded. So, if you wrote 1 + 1 is 5, that's crazy. Could you please regrade this question?
I wrote 1 + 1 = 5.
Then you hit submit and it will all get regraded by the same person. Okay, so I'm not doing the regrades. We've got an assistant coordinator who's going to take care of that. But any concerns you have, please forward them to this. Overall, people did really, really well. I'm glad with how people did. So things are going well. The grade distribution is kind of nice. We've got a lot of people above 60. That's always a good sign. So yes, so keep up the good work. We've got another term test coming up, right? We've got one at the end of the month. So November 29th. So November 29th, we've got another term test. And then after that, we have our exam. Okay, so our exam is coming up really crazy fast. Our exam is December 14th. Is that correct? 14th? Classes end December
4th, I think.
December 4th?
I think so.
Okay, so let's check the syllabus.
What is that?
Yeah, so for us, our last class is Wednesday, December 4th. Okay? So it's our last class. You'll notice that we're headed into a sort of a slightly lighter part of the course. In the time before reading week, we were doing like 5 sections a week. It was totally crazy. Now we're going to go a little bit slower. Mostly 1 section a week. Okay, and then we've got our exam coming up early December 14th, I think. Thoughts there, questions there? Okay, so I encourage you, if you have any questions about grading, you want anything regraded, please use this form and we'll get your mark regraded. Okay, so we're headed into another part of what makes multivariate calculus different than single variable calculus. So we have this technique called change of coordinates. talk about how this relates to the single variable theory. Okay, what process in single variable calculus is like change of coordinates? Okay, so in single variable calculus, we can take integrals and we can change the variable of integration. So we can say if we're lucky and have a situation like this, right, where we've got function g and its derivative, right, then we can reparameterize the real numbers. We can rewrite the real numbers by saying that we're going to call that g of x, we're going to rename it as a u of x, and we get something like this. Okay, what the effect of this is that it relabels the real numbers. So I want to show how we can kind of generalize this to several variables. This changing of coordinates, or this relabeling of the plane. Okay, so when we want to do this in two variables, there's a couple things to notice. So first off,
Two substitutions.
yeah, we've got multiple substitutions going on, right? X is changing, Y is changing. And what this allows us to do is it allows us to change the shape of the region that we're integrating on. So here we start off with a rectangle. Right, so we start off with this 2 by 3 rectangle. And we're going to rewrite that as an integral over a smaller region. Okay, so here we're in coordinates that we're calling x and y. Over here we're going to call them u and v. So we sort of get a sort of a more symmetric, nicer square region than a rectangular region. So one thought we might have is to just change the bounds, kind of keep the function the same, right? So here we started off with xy, and now we get uv. So we changed the bounds, but we kept the function the same. Should that give us the same integral? No, we're getting some sort of shaking heads. Why will this give us a different volume than the thing we started off with? Yeah, right, so this, yeah. So we're taking the same guy, but we're going on smaller bounds, right? So we're, orbital. Right, if we switch the bounds but don't switch the function, we wind up on this tiny subregion. Right, we get the volume above this guy. Right. So this will not work. The volume calculation wouldn't work out. Okay, so we somehow need to change the function and change the bounds at the same time. So what we need is a function that goes from xy coordinates to uv coordinates. Right? We need to somehow relate these two coordinate systems. Okay, once we have that function t, we'll wind up switching our function in here a little bit. Okay, so we want a map that goes from uv to xy. Right? We want to take this rectangle onto this rectangle. So what's a map that would do that for us? That would map the square onto that rectangle.
Can't we go? Oh, so we need a function.
Right, we want to stretch this guy by a factor of 3 and this guy by a factor of 2. How do we write that down as a function?
Transformation of matrix.
Maybe take a moment, chat with your neighbor about it. Try and come up with a function that would map like that. Okay, so just take, let's say, 2 minutes there.
Is it 3 plus y? Hmm. 3x plus 2y.
We want 2 outputs.
Sorry?
You want 2 outputs. Right? You want an output for x and an output for y.
Oh,
It's two inputs, 2 outputs. Yep.
Can we make an formula for the factors?
Yep.
Yeah, a vector or a matrix could do this.
I did the same.
Nice.
And then in algebra, we did the same. That's what it's why. Given by transfer, what does that mean?
So we want this direction.
Yes.
Yeah, that worked great.
I just know that. Well, now. Sorry. How do you know? No.
Yeah.
We will.
It's kind of invertible. Yeah. Yeah, that'll work great.
0 to 3 equals 0 to 3. Just do the matrix.
Okay, so we want a map that takes the stuff in UV and outputs stuff in XY. Okay, so how can we make such a map?
Matrix transformation.
Yeah, did anyone try matrices? Anyone do sort of a 2-2-3 kind of thing? Lots of blanks there. Definitely no. Not a chance. And that's okay. So you wanna stretch 0, 1 onto 0, 3. What's a map that'll do that for you? Yeah?
Wouldn't it be VU plus VP?
We need 2 outputs.
Oh.
Right? So I like your idea that this will be 3U. What should our second output be? Right? We want to get a 2V here. So yeah, this is kind of a weird thing. This is a function that has 2 inputs and has 2 outputs.